The Great Search brought to you by DigiKey and Adafruit. Every single week, Lady Ada uses her power of engineering to help you. Yes, you. Find things on digikey.com. Lady Ada, what are you looking for this week?
Okay, so this week, let's go to the overhead real fast. I'll show off my stepper motor driver. I've been working on these stepper motor drivers to drive bipolar stepper motors using the TMC2209 and friends. There's like the 2130. There's a couple other chips I'm looking at from this family, but I'm kind of getting like, I kind of got like the best, right? It's like I don't have every peanut butter, but I have like the 3 peanut butters everybody wants. And so now people are like, well, if you're getting into motor control stuff, we have some requests for you. We want you to do some brushless DC motor drivers. And I'm like, I have never done brushless DC motor stuff. A lot of it is honestly used for like robots and quadcopters, which is cool. I've just never like done those. I mean, yeah, I've just never built my own scooter. I'm kind of like scared of anything over 20 amps, to be honest. It's like, that's a lot of amps. But these little brushless motors are used for fans, used for like quadcopter motors, used for robotics and stuff. I thought, yeah, maybe it's a good idea for us to stock a really good, easy to use, getting started, your baby's first brushless DC motor driver. So I thought I would go over, and then I did get one thing that people kept, like a couple people asked for FOC, and I'm like, I have no idea what that is. So I do have to look what that is. It's some sort of like, I think, a feedback control mechanism, which makes sense. One thing I've noticed as you're looking at chips is like, what are the features that are available? One thing that is nice is that apparently you can get ones that are sensorless. So like older motors you'd use, I vaguely remember this from like my 6115 lab, is you would have, you can use Hall effect sensors to detect like where is the motor spinning, but you can also use the back EMF as a sensorless way to detect like, is the motor moving? How fast is it moving? And if you want to stabilize on a speed, for example, you can do that because of course the speed is like these brushless motors, the speed is going to be so variable based on the voltage and the wind and the humidity and how it feels that morning. So let's find on DigiKey a brushless DC motor driver. And I'm lazy. I want it to have the FETs inside already. I don't mind adding, maybe if you have to have some protection, whatever on the outside, some flyback diodes, but I really want at least the FETs to be on the inside. And I would love to have digital motor control like the TMC2209 and friends. And it would be really, really cool if I could do that like over I2C, because it's like I'm getting used to just doing stuff over I2C and having an I2C controller. And then like a fair amount of current and a fair amount of voltage, and then we'll see where we end up. So let's go to the DigiKeys. Okay, so we want to search for BLDC, brushless DC. I have to say that out loud because it's so easy to mix up all these characters. Okay, they have motors. I will have to get a motor. Maybe next time I'll get motors, but a lot of them are fans. It's true. Let's get a motor driver controller. So a lot of options. So first I want to start with, of course, only active stuff. This is an active product we want to design, and I want to have something that's normally stocking, and I'm going to exclude marketplace for now. So that gets us down to like 500-ish out of the 1,500 available. Looking good. A lot of little options here. There's like low cost ones. There's this is clearly part of that family. It's the 4988. They also have the 4931. That's kind of cool. Maybe I'll check that out later. And other DC motor drivers. I definitely want one that's only surface mount. And motor type. I want brushless DC. I mean, these all kind of are. Maybe I'll just clear this because it doesn't really matter. And the interface. And so a lot of them are like SPI or step direction or something. But like I said, I really want to see if I can get one that's I2C. So let's search for I2C, and that filters them out, and then I'll select all of them. And that gets me down to like 50. There's not a lot. And then finally, general purpose, what I want, as I've learned from the stepper motor drivers, is I want the fully integrated version, because that's what I got for the TMC2209 and the A4988. I don't want external FETs. Cool, you want 50 amps? get your external FETs going. I'm going to do something chill. Again, babies first. Motor driver. Okay, so now we're down to 30 options. And all these options were actually pretty good. A lot of different companies. Maxim's got some options. This one is actually kind of limited though on the voltage, which I didn't like. It was really low voltage, so I thought maybe I would. I want it to be at least up to like 12 volts, I think, or 8 volts. So I'm going to just filter out all these like 3 to 5 volt only motor drivers. I mean, I'm sure there's a reason to use them, but I want to limit that. Then there was current output. So, 250 milliamps is crazy small. That seems really small. I don't think it's that little. Maybe it is. But I like some of these are like 2 amps, 3 amps, 4 amps. And then I tried, filtering by price. I'm not that price sensitive on this because, they're not going to be that inexpensive. You do get a lot. And there are a couple options to get Allegro. And they have, like, again, this FO, what was it? The FOC? This has, sensorless. You don't need, you don't need to have sensors on the motor to tell where it's at. And then I saw this DRV 10975 series come up a bunch. And this looks really good. It has up to 1.5 amps, I2C, back EMF control. Like I said, you don't have to have, sensor stuff, external sensing stuff. Built-in, step down, all the thermal, whatever, for fan control. I like to look at this application schematic and I'm like, there's just not a lot going on here. I like that this has speed and direction as well as I2C. This one looked really good. I'll say, by the way, I'm not even though I'm picking one in the end here, it's not the end all be all. I might actually make one for a variety of these drivers. The one that I thought was really nice that also had this thing that people are asking for. The MCT, hold on. These were very confusing because there's a lot of them. The MCT, we no longer filter by price. Sorry, the MCF series had the sensors field-oriented control. Again, I don't know what that is, but I've been asked to make one with this. So I'm probably going to go with this to start. Another thing that's really nice about this one is 8 amp peak, which is like huge. You can do speed over PWM analog or I2C direction brake. Has the MOSFETs built in. 8 amp current output. Can do 4.5 to 35 volts. This is like kind of a nice little beast. Built-in LDO, built-in buck. A lot going on here. It's, not cheap, but it looks like there's it's in this family. So this is the version which has that feedback control system, and this one doesn't. So I might start with this one and then upgrade to this because this is clearly, hopefully it's actually pin compatible to the MCT and the MCF. But this one's less expensive. I can start with this. So this doesn't have that feedback control, but it does have sensorless, and it has that same interface. And then as I kind of get used to using, it's kind of cool. It has a variable monitoring with the DAC. As I get used to working with BLDCs, maybe I will upgrade to that 8 amp version, which is like a little scary, but also looks like a pretty cool chip. So I'm going to start with this one. A lot of really good options for the BLDC. Like I said, I might end up going through and doing the rest of them, but I'm going to start with this one, the MCT 8315A, and then bump up maybe next time to the MCF 8316, part of that same family. So good stuff coming if you like brushless DC motors.
That's a great search.